Okay, perfect. This is visible, right?
Yeah.
Okay. Okay, let's start with same. We'll do quick revision. So we started with our first lecture, all the terminologies. Basic one, we did from the anatomical position. This is my anatomical position. We go for flexion, away from it, extension, and down, like closer to the anatomic position. So I'm away from anatomic position, closer to anatomic position. If I talk about legs, same thing. This is my anatomy. This is away, flexion, and coming back, extension. As simple as that. Now, next one, we talk about few major things in the last lecture. That is our base. So we discuss about force. You don't have to go into the mass into acceleration thing. Of course, that is true, but we just want to simplify thing with respect to what is force and how we are feeling it. So anything, if I push or pull, that is force. That's it. Okay. And when we talk about exercise, any form of exercise, you like playing sports or anything, we are applying forces. So exercise is nothing but applying force. It is external force application. For example, this is a ball. This is providing some force to my hand. External force application versus internal force production, which is producing by my muscles. So this is the basic definition of exercise. Now, we draw some momentums. What force is having is point of application, magnitude, and what all we have? Yes, magnitude, the weight, the direction of the force, and the point of application. My arm is the point of application. These three things force contains. Now, we feel whenever we go to gym, only we focus upon the magnitude. Like I'm lifting 5 pounds, I'm lifting 10 pounds. But actually, in the full range of motion, your resistance is changing because the resistance is not the force or the weight. The resistance which you are opposing is torque, the rotational force. So we discuss about torque. Anything, it is this is my joint and this dumbbell is here. So if this dumbbell wants to go down, but because it is attached to some axis, it will go in a circular motion. That rotational force is known as torque. Now, if we talk about the definition of torque, it is moment arm into force. So this is the force. Now, what is the moment arm? Is the distance, and moment arm is the distance from the axis of rotation, perpendicular distance to the line of force. Okay, not the point of application, it's the line of force. And we always create an imaginary line of force extended to make things easier for ourselves. We did some examples like bicep curls and the direction of force. Like if I'm using band, there's a different direction of force. If I'm using dumbbell, there's a different direction of force. Same thing you can try for lateral raise and abduction, adduction, and at different points you can get to know what is the line of force and momentum. You don't have to really calculate the torque, but you will get to know if momentum is decreasing, your torque resistance is decreasing. If momentum is increasing, your torque is resistance is increasing. So, Mani, did you check out the pics I've shared on the group about the bicep curls?
Yes.
Did you get the difference? I think you were asking the same thing, right? If I'm doing with the band, same thing, we can do it with the cable curl also. You can draw same thing with the cable curl, because you can see the direction of force at different position. Now, this is our previous lectures. Now we go ahead and we build upon that one only. Well, we were discussing only about one joint, one line of force till now. Okay. Let's, because for drawing free body diagrams and understanding exercise, we need a lot of practice with respect to different exercises. Now, I will show you the free body diagram of holding on two joints. So we'll just discuss only for two joints. So let's take the example of this one. So this is like, I know this is a flower, but you have to imagine this is the direction of force. So this is a like direction pointing downwards. Now imagine I'm holding a dumbbell. Okay, I'm holding a dumbbell and I want to go up, right? We are doing shoulder press. Now, when we are doing shoulder press, this line of force, this dumbbell which I'm holding, the line of force is going straight. And we'll talk about two joints for now, elbow joint and shoulder joint. But let's divide it more and we'll just talk about only the elbow joint. Okay. So, you know the direction of force now. This is the dumbbell. Okay, this is the dumbbell. It is in line of force is in same direction with the joint. So you're not actually feeling anything on the elbow, right? Your biceps and triceps aren't doing anything much. Now, let me take my arm forward. Now, if you see, if I take my arm forward, this is the direction of force, down. Now, to hold at this position, my biceps has to activate it, else my arm will fall. So, I'm doing some work here. If I not use my flexors, my biceps, it will fall. Because this is having a line of force down and it wants to basically throw me down. Because of this excess, it will take me down, right? So this is the line of force. If I open up my arm, I'm doing some work in my biceps. This will be your shoulder and bicep exercise. If I go for shoulder press like this. Now, let me change it inside. Now, if I change it inside, this will be my, like, yes. This will be my direction of force. This will be my direction of force. And now my triceps has to work. Else, this dumbbell, what is doing? It will hit me. If I not hold, if I not stop because of triceps, if my triceps won't work, this will hit me. Right? It will hit like this. So what you want to hold it. So right now your triceps and shoulder is working. Now, let's draw this. Okay. So we'll be adding two more concepts today. First one, we'll just do a free body diagram of, as I said, of shoulder and elbow. Now, let's take this one. Okay. This is my elbow joint. This is my shoulder joint. And I'm holding the dumbbell here. Now, this dumbbell is applying force downward. So this is your line of force. This is your line of force and your elbow joint is having. So there is no momentum at elbow joint. There is no momentum at elbow joint. That's why you're not feeling on your triceps or biceps. It is this resting position. Now, let's take another one. This is the dumbbell. This is the dumbbell. And this is the line of force. And this is my elbow joint. This is my shoulder joint. Now, if I draw a moment arm from elbow joints, this will be my moment arm, 90 degrees. So I'm creating some moment arm. Because of that, my biceps is activated. My flexor muscle is activated, right? And if you think logically, and if you imagine this dumbbell wants to push me down. If I leave it, it wants to go down. So the line of force is down, but this dumbbell will go there because of my axis. So my biceps has to hold it strong to control this so that the dumbbell won't fall. So this is the moment arm. Now, third one. Now I'm holding the dumbbell here. We are all in this movement. We are doing a shoulder press. But how, when you change the position, your muscle group can change. So you can make your shoulder press exercise as shoulder triceps. You can make your exercise at shoulder biceps. Now this is my elbow joint again. This is my shoulder joint. Now this is acting down. Line of force. This is my line of force. And now if I put a perpendicular distance from the elbow joint, it will be right here. So this is my moment arm inside. Now if I talk about shoulder, let's imagine shoulder joint. Okay, let's go. So we were discussing everything about elbow joint. Now, if I talk about shoulder joint, so this is my shoulder joint, shoulder joint, shoulder joint. Now, at this position, I'm not feeling anything on my bicep, tricep, or on my elbow because there's no moment arm. But now the line of force is here. If I calculate the moment arm from shoulder, there's some moment arm. This is my moment arm from shoulder joint. And that's why even in this position, you will feel some resistance on your shoulder. This is my moment arm. Now, if I calculate about this one, for this one, so this will be my moment arm for shoulder. See, this much big. That's why if you're doing exercise like this, because of such a big, huge moment arm, there's a lot of torque is there, a lot of resistance you have to hold. Now, if I talk about this one, the tricep one, this is your moment arm, perpendicular distance on the line of force from the shoulder joint. So we have some moment arm, but not this big. So we have some decent amount of moment arm. We are experiencing some resistance also. So the point is, if I change the direction of my dumbbell from here, 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 I am changing the muscle group as well. Why I'm telling you this? Because if you go to any gym trainer or any gym setting, and they might be talking you, okay, you're doing shoulder press. No, I'm doing shoulder press. I know, but logically, I'm doing a lot more than that. If I change my arm like this, I might be doing shoulder biceps. If I'm doing this, shoulder triceps. If I'm doing here, I'm just working on shoulder. It's a different position. There is different resistance which you are experiencing and your muscle group is feeling. This we should know because the forces actually we cannot see. We can just feel it. Tell me this is clear. Even if it's not, it's great. It's totally fine. We'll just again, step by step, as many free body diagrams will make, you'll get the clarity. But start making some of the free body diagrams on your own. And when you're doing on your own, just one line of force and one axis of rotation. You just have to focus only on one joint. Don't confuse yourself with multiple joints. Okay, tell me, Neil and Mani, did you get some idea about this shoulder press movement and how we can change the exercise experience?
Yes.
Okay, Mani, you're also a little clear?
Yeah, Samir. I got it.
Perfect. So this is we did for shoulder press. Now, next part we have okay. Now we did for the two joints. Next one we are going to do the when you go inside a gym setting, we experiencing not just single force. Let me explain again. So imagine this is my dumbbell, 5-pound dumbbell. The line of force, you can see it's straight down. Now, I'll add. Now, I'll add this band as well along the dumbbell. You're getting it? So now there are two lines of forces. One is in this direction and one with the dumbbell going straight down. Because whenever we are doing different exercises, we are experiencing different kind of forces. Let me explain this again. Okay, so this is my 5-pound dumbbell. I added one more 10-pound dumbbell, 15 pounds, right? But both are having same line of force. So let's draw it again. We'll do the elbow thing. Oh shit, my drawing. We'll do the elbow thing. Now, this is my elbow. This is the dumbbell I'm holding. So the line of force is this one. Now I add one more dumbbell on top of it. The force double. Like this is 5 pounds, this is 10 pounds. So the force is 15 pounds total. So here I will add one more arrow. So this will be F1, this will be F2. The combination of both. Same thing. This is the line of force. And if I'm doing with this resistance band, you can see there are two line of forces. One with the dumbbell and one the band is taking down. So we have two lines of forces here and we can have multiple lines of force. Let's take one more example. Okay. This is the resistance band I'm holding between two legs. Now I lift this. So if I lift this and it will straight go down because this thing, the one force is in this line because this wants to pull here and this force wants to pull there. So there are two forces right now. That's why it's going in the center. So now which force we are talking about? There's one force here, one force here. The resultant force will be in center. That's why it is going straight down. I'll give you one more example. we apply pulling something, or take an example of tricep extensions with the rope. So we do tricep extension with the like tricep push down with the rope. If I pull this more, this will go this side. If I pull this more, this will go this side. But I'm maintaining a balance. So there are two forces, but there's one resultant happening. So anytime in the exercise experience, we have to take care of multiple lines of forces as well. Let's draw it again. With the bicep curl, I'm giving you different example for the same thing so that we can understand. So this is the dumbbell. Now I'm holding one force here as well as a resistance, so resistance band. So there's a resistance band also. Now this is a 5-pound dumbbell and there's a 5-pound force from the resistance band as well. And this band wants, this dumbbell is here. Okay, now the resultant force will be, if I draw same here and here, this will be my resultant force. So you have to make a parallelogram. This is a parallelogram. Make a parallelogram and draw the resultant on the center. Let me try to make it a little clean. Anytime if you are getting any doubt, guys, ask me. Okay. Let's draw this again. First, we were drawing a simple one. We have one dumbbell in arm, another dumbbell in arm. So with 5 pounds, I showed it with this arrow. Now the second also is there. I've showed it again with one more arrow. But if I take a total, this is a full, this will be my resultant force. Addition of both. Now the line of force has been changed. In this, the line of force is same. But now the line of force is changed. One is with the dumbbell and another one is there of the resistance band. Now the dumbbell line of force is straight down. So there are two line of forces, F1 and this is F2. At this situations, you have to make a parallelogram, like one draw line here and the another one here. Now, if you see the resultant, it has been here and the resultant also increased. So the resistance, sorry, the force has been increased here because we added two things. Most of the time, if you see people doing deadlifts using dumbbells as well as bands, they're just playing with some more lines of forces. They don't know it, but that's how it can benefit also them. And sometimes basically don't think about benefit or not, but that's how you change the exercise experience of any exercise at the given point. Because of two lines of forces. And now, we discuss this one, resultant forces. I've given you example for tricep push down also. We are pushing the tricep down, so there are two forces involved and we are taking the resultant. So anytime you can see there are more than one force involved or one or two is involved, take the resultant force. And That how will come? You have to visualize the forces, because as I said, in real time, you cannot really see the force. You just need to visualize it. So that's why the practical advantage, that's why we are not doing any calculations there, because calculations might not help, but you can change the exercise experience with respect to the line of forces. If I change some line of it, so you can visualize the line of force and the momentum. That's more than enough to understand about the exercise. Okay, now we discuss about resultant force, this one. Now another concept, which is a reaction force. I'm pretty sure everyone have heard about third law, Newton's third law. But again, as I said, we're not going to terminologies of physics. We'll try to visualize it. Now, let's take this back. Till here, resultant forces is clear, right? Mani, Neil, Ashutosh, you joined late, but just keep saying. Okay.
Yeah, sure. I'm on the way actually.
Cool.
I'll just join.
So this is the resultant force. Next one, we are talking about the reaction force. So that was resultant. This is different concept. Newton's third law, but will not use those terms. If I stretch this band, you can see this band wants to pull me back. This is visible, right? Now, let's take this. I'm pulling it. But this one does not having any stretch property. So it doesn't mean it is not pulling me back. If I'm applying force here, this will pull me back as well. Let's again take, if I push this wall, this is not going to move it. But again, this is giving me a force back. This is pushing me back. Let's take example for handstand. If I'm going on a handstand, if I apply force on ground, the ground will be pushing me back as well. So I can hold a little longer as well. That's why you need to grip the ground, like push it. Because you need the ground force as well. So these forces, it's not visible. With the band you can see, because it is having a stretch property. So you can see this is going to pull me back. But anytime, like with air, water, like if you dive into the water, you're swimming, the water is also pushing you back. So there's always one reaction force involved. Anything you do. Same thing with the exercise. If I'm pushing something, maybe that thing is moving or not, that's okay. But that thing is applying a reaction force. Let's take an example for pull-ups. I'm holding the bar. I'm pulling up. So the force is down, which I'm putting. But there's one force which the bar is applying, which is up. Because if I'm pulling the bar down, the bar is applying one force up. I know the bar is not moving, but still it is helping me and applying some force. Okay, so this point you are clear with it, with these different examples, because sometimes even the even if you cannot see the movement, but still the force is present. Let's take a lat pull down example. Okay, so this is the lat pull down, right? Now I'm doing with maybe 40 kgs, I'm pulling it. Maybe 80 kgs, again I'm pulling it. 100 kgs. Now, instead of I'm pulling it, the bar is pulling me up. So the reaction force was there all the time, right? But now the bar is applying the weight, because of the weight, The bar is applying more force. That's why it is pulling me up instead of I'm pulling it down. So did you get this point about these two things? First one, resultant, and second one is the reaction force. Is it clear? Or
I think there should be another explanation once more.
okay, for the reaction forces or the resultant forces.
Reaction.
Reaction forces. Okay, so let's.
So before you start, resultant force is the one that, for example, we are doing our cable push down, or the force that if there are two forces, the result of two forces will be the force, right?
Yes. So
Resultant force.
that is decide the direction. Imagine there is one guy. Okay, this is the bar. I'm holding the bar from here, and one guy is pulling from there. So if we both pull from equal amount of force, this will go straight. This will not come in my direction or the other guy's direction. This will go straight. So like if you can see, one guy is pulling from this side, one guy is pulling from this side. So the resultant will come in center.
Yes.
In this side or that side. So this is the resultant force always. Let me show you an example. So this was the resultant for resistance band and dumbbell. Like we draw two line of forces. Let's take an example of sledge. We always pull sledge, right? Like push or pull sledge. Now imagine we are pulling with the rope. There is rope. जो हम tricep push down में we use it. So there is a rope. So this is a sledge. Okay, sled. We push sled, right? Now there's a hole here. Now there's a rope here. One's this side, one is this side. Now one guy is pulling it from this side. Now one guy is pulling from this side. So there's one force in this direction. There's one force is in this direction. Now what you want to do, the resultant, if you make a parallelogram from there, so we make a parallelogram, the resultant force will be in center. So what happened here? If this guy is pulling, suppose this is me and this is you, knee. We are pulling with both equal amount of forces. Logically, we know, okay, this sled is coming straight. But if I start visualizing the force, this is the force I'm pulling, this is the force you're pulling. If I make a resultant, so that's why because of the resultant force it is coming, the sled is coming into the center. So my point is we usually not see the force, but logically we feel, yeah, this thing is happening. For example, tricep push down, how many times we do tricep push down? But why you don't do tricep push down like this? Or why not like this? Because we are applying equal force, right? We are applying
both the sides. Yeah.
the weight is coming in the center.
So if you are doing an exercise which has a resultant force in the center, then you can determine that exercise is better for your muscle.
No, don't. Okay, I'm not okay. So as I said in the last lecture, we are not discussing which exercise is better, which exercise is difficult. Right now, work on the concepts. Only concepts. You don't want to determine with just one concept. Okay, what happens because I have not completed the concept. Last lecture, I have only explained you the forces. This lecture, we are building upon those forces. Like last lecture, we just discussed only one joint, one line of force, right? only one line of force. In this lecture, we are discussing two line of force, and there's one force involved, which is reaction force, which you cannot see. Like with respect to this bar, I showed you this example. If I'll do this, you know, this will come back. The band will come back because band has that stretching elastic property. Correct. But if I do with this, if I try to pull it apart, I cannot pull. You cannot see anything. But still, this bar is pulling me in. Try this one. Like if I pull apart, this is still pulling it in, though you cannot see. So my point is here, you don't have to analyze right now which exercise is better, which exercise is difficult. When you understand these different concepts, then you can analyze, okay, there's some exercises where resistance is constant all the time. If I do fast, if I do slow, the resistance is constant all the time. Okay, it makes sense. Now, if I'm feeling same amount of resistance here, same amount of resistance here, is it good for me or not? If I reduce resistance here, if I reduce resistance here, is it good for me or not? Right now, just conceptualize this. The difficulty, exercise selection and all, we can only decide when we are aware of all the concepts. I'm not saying you can always understand all the concepts and like say, okay, this is the best exercise because the resistance is also good. You're doing with band, your line of force is good. No, you cannot do that as practically. But if you have a good understanding, okay, this is the force, these are two lines of forces, and okay, now I can see it better why I'm feeling on my biceps or why I'm feeling on my triceps. Most of the time you went into the gym, you feel while doing bicep curls, why you feel on the bicep? Because the force is acting on it. So we need to just, but our brain, how it works, for example, I'm teaching you the concept, but my brain is connecting me to the exercise part always. So you start immediately thinking, okay, if I do this exercise, this might be better and the resultant force is coming. No, we are just building upon the forces, resultant force, reaction force. And with few examples, you can see, like, for example, I've given you shoulder example. If I'm doing shoulder press here, there's nothing happening at elbow joint, but there's a lot happening in shoulder joint. But if I do shoulder press like this, now my biceps is activated. If I do shoulder press like this, my tricep is activated. So you have to start visualizing these things to understand exercise better. For example, right now, maybe you're Googling some exercises. Okay, this is my circuit. I'll just show it to my client and he is going to do it. But maybe that person is having some pain and you have to design a structure particularly for him. So if you're aware of these forces and exercises, you can plan it better. You don't want to do some exercises which impact his bicep because he have some bicep tendinitis. Okay, but still you want to train. That's where these concepts will come handy. So let's continue with this. I've given you, so did you understand resultant force? And with these examples, only simple examples we'll take. We don't want to call complicated.
Yeah.
So this is your reaction force, which always present. That's anything. Like if I'm doing a push-up, the ground is again giving me some force back. If I'm doing handstand, it is, I cannot, but it is there. I can see with respect to the band because the band is having that property. So I'm able to see that reaction force. But other than that, those reaction forces are present, but we cannot see. Same thing with the resultant forces. If I'm pulling something here and one guy is pulling here, the thing is moving in the middle. But we find it's pretty okay. It's pretty obvious how this is happening because two forces, and if I make a parallelogram, there's a bigger forces involved. So that's why this is come in handy. Now, I'll give you, we're not stopping here. You understand the basic of these? I'll show you how we can implement in one of the exercises. How these two forces will be implemented in one of these exercises. Okay. Let me show you. We know all this exercise, right? We might
Yeah.
have tried out. Okay, cool. Now,
Yes.
I want you to, and where we usually feel it. You tell me, guys, first. Where we feel it when we do a squat hold? Where we feel it?
To some extent, hamstrings, your quads.
Yeah. Most of the time, you will feel all quads. Like, okay, so there's
Quads.
a tester or something, but you just go sit in a wall squat and feel. Just do it for 30 seconds only. You start feeling some muscles are working. So most of the time, your muscle which is working or your quad. But how this squat?
Quads. Yeah.
Okay, open up. Shit. Okay, so how this squad is working. So right now, I just want you to focus only on one joint. If I take it full, there are multiple forces involved and joints, but
Multiple
we'll
joints.
just
Yeah.
work only on this part. Okay, you can see this, right?
Yeah.
We have one joint, knee joint. We're just going to see knee joint. Okay. And I will draw this in picture also. You can draw forces. That's the same thing which I sent you over the group. So you can do that also, or this free body diagram, whichever is comfortable. But if you draw those, you can visualize. Let me clear this off. And next.
Sumir, I think you can use a whiteboard on the Zoom app so that it will be easy for everybody. There will be
I know, but I'm not that much handy with that. That's why I'm using this one. But maybe when I'm like
no problem, no problem.
next batches, I'm pretty comfortable with that.
Sure,
I'll
sure. Yeah.
start using that. Okay.
Sure. Yeah. No issues. Yeah.
Thoda sa old school type. Okay. So let's take this one.
Yeah. I love that. Yeah.
It's okay. I get it completely. But this is, I'm doing a squat hold. Okay, this is the wall. This is my knee joint. And this is my foot.
Yeah.
Okay. So there is one force. I'm on the ground. I'm applying force down. But there is one force which is up, which is the reaction force, right? We have just talked about it. So there is one force down, but there's force applying up. This is reaction force. Okay. So this is the, okay, let's take this. So this is the reaction force. And how much you apply it, this is again going to push you up. Now, this one more thing is happening. Can you see what is happening here? Or I'll show you the picture. We have not discussed about it, but okay, again, whenever I ask these questions, if it's not a test or something, it's just like, it will help you to remember things. Okay, he has given me this example, or he has asked me this question.
Muscle memory.
Yes. So now there is one reaction force which I've already told you, but still there's one more force involved here. Can you identify that? Okay, let me take that as no. And let's go for gravity is always present. So I'm pushing the gravity, the reaction force is always. Okay, tell me this. Okay, so I'll throw the ball. Now it is going and it got stopped.
Internal force of the ball.
Okay.
I mean internal force of your muscles.
No, अभी तो हम internal बात नहीं करेंगे. Ball, मतलब simple. Let's take it simple. Why this ball stopped? Okay, let's do this. I'm doing a
because
Abhi, ground pe, there is a ground. I'm walking. Now the ground is having water and I slipped. What happened? Or suppose if I'm doing a squat, the same wall squat on the ice. What will happen? I will fall, right?
Yeah.
So that slippery motion, how is it coming? Because of friction. If I'm throwing this ball, nobody is externally stopping it. Nobody. I did not touch it. Ball, if ball can keep on going, but something is stopping it. That is the ground, the force exerted by the ground, friction force. Same thing. If I show you this, if I'm doing on the ground, if I am doing this on the, suppose, ice, I cannot hold this position. I will slip. So there is some element of friction force involved, which is exerted by the surface. Now my foot is wants to go forward, but who is stopping it? The friction force. So there is a reaction force by friction. Right? Did you get this point? We are just talking about the knee joint. There's one force
Yes.
when I'm pressing the ground. So the ground is pressing me up, but the foot wants to go forward, but something is stopping that. That is stopping the reaction force of the friction. If you see other examples like ball is stopping, or if I'm doing this on ice, it will be pretty tough to hold this squat because you will fall. You keep on falling because there's no friction. So there is one force here. Now, if I take a resultant of these two, let me draw a resultant. Tuck, 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 tuck. Now, this is my resultant force. And if I go stretch it, see where it is going. It is hitting my quad somewhere. It's not the exact accurate diagram, but you get it, right? There is one resultant force which is going through my quads. That's why I feel force on my quads while doing squat hold. Now, how I can change the experience of this one? For example, I add some weight. There's more force I'm applying down. Same amount of force ground will apply again up here. Now, and I purposefully will push forward more. So I'm trying to push forward more. The friction is stopping again more. Now, if I draw again the reaction here. So now the reaction force is almost going here. It's still on quads, but there's a big muscle quad. So I can change the experience with just feeling it, like if I'm purposefully, intentionally pushing my foot forward, or placing some weight. That's how you can play with the force. Did you get this point or not? Or I'll explain again the squat analysis. Something.
I understood it.
Okay. Mani, did you get it? Thoda sa.
Yeah. Yes, Sumi.
So even if you didn't get this point, just take it slow and revisit and think, okay, this is happening. Right now, you don't have, I'm not telling you right now, which is the best exercise, which is the exercise you want to do or not. If you want to just know that, did not want to know this, we'll come to that part also. Like when we talk about programming, how to program for yourself or client. But these forces will help you to understand better the exercise. I'm teaching you the core thing where it will be easier to understand. Okay, else whatever you're doing in the gym, you can continue doing it, but start visualizing things, what is happening. You have to just visualize the line of force, momentum, and only with one joint. Don't confuse yourself with multiple joints. What is happening in my elbow joint, knee joint, because your all the joints are involved. That's why the concept of compound movements and isolation movements is, they have made it oversimplified for people. Okay, so that people can understand that squat, deadlifts, these are the compound movements, but isolation are your bicycles. No, even in bicycles, my shoulder is also involved, my bicep is also involved, my wrist is also involved. So we need to start questioning things. That's what make you different as an athlete, as a coach, and this will make your clients a lot better also, and this will build your authority that you know things. And I'm not saying you know the wrong thing, you know the right way, right path. Okay, so let's summarize this quickly. We discussed about the forces which we cannot see, resultant forces, and how you want to draw these resultant forces, always with the parallelogram thing. So if two forces are here, make one here, make one here, make a parallelogram, and the resultant force you can draw. Okay, simple example with the bands, you can this is the resultant we done. Now the reaction force. Reaction force, if I'm pulling the band is pulling me back, and the reaction force is happening all the time. If I walk, ground is the ground is pushing me up. If I'm like most of the time, if I dive into the water push me up, and if I'm pushing the wall, I'm not moving the wall, but still there is some force which is equal amount of force. Actually, the wall is pushing me back. So these are the reaction forces, and we did different movements of squat analysis, why we are feeling on the quad with respect to the only knee joint, and the resultant forces adding frictional force as well. So there are forces involved which we are not able to identify, but they are there. And we last thing we talked about two joints as well. We did a free body diagram of two joints like elbow, shoulder press, elbow and shoulder joint. That's it. So if you got some clarity, perfect. If you didn't get clarity, it's totally fine. Slowly start building this concept. There's some homework, like for example, in the last one, just start doing the external momentum thing, external momentum and the line of force. That should be good enough to learn about exercise. Okay, that's it. And if you have any questions, go ahead and ask me. We'll just stop the lecture here. And I hope you got a pretty good understanding. And thank you again for joining this. Let me know, guys. Or if it's clear, it's totally fine. And the lecture again is with you. You can just revisit it and see the free body diagrams, how I have made it. And you can just start drawing some of the things. But whenever you're doing it, always go one line of force, one joint. Don't confuse yourself with multiple joints and all. Simple exercises.
Yes.
When you are comfortable with those exercises, then start adding multiple joints or multiple line of forces. Till then, just stick and get comfortable with the vocabulary. For example, flexion, abduction. If you're still confused with abduction, adduction, all those things, work on those first. Then slowly build it. Perfect.
Yeah, Sumer, I have a question.
Yeah.
I don't know if I missed it or not. So, do we have planes of motion coming in?
I have already discussed in the first lecture, the sagittal plane, frontal plane, and the transverse plane.
Okay, I'll go through it.
Yeah. So first, not the first lecture.
Second, I think.
Second
The
lecture.
third
Yes.
must be.
Second lecture. Yes.
Okay, I'll go through it. Yeah.
Yeah. So second lecture was all about kinesiology. You can just revisit it, and even in a third lecture, if you want to go for third lecture directly, you can go for it, because I think I just did. I try always just to, for a start, do a quick revision so that it reminds you, okay, what we are going to talk about, and then continue thereon, because we have to build a lot, Abhi.
Yeah.
When we build the concepts, then it will be easier for you. Okay, I have to plan this, but because these concepts you cannot see, it's just we have
So
to
take quick. Yeah.
Yeah, apply it, and we have to feel it.
Yeah.
Okay. Okay, that's it, guys. Thank you so much for joining. Have a great day ahead. Good night. See ya. Bye bye.
Thank you. Yeah. Thank you, Sumit. Bye, everyone.